Thanks, Ken. Feels strange being up here. 10 years ago, when I came to my first Sustainable House Day, I looked up at Ken and Mark and said, I want to be those guys one day. Look at me now, I'm standing up here trying to crack jokes like these two, so it's great. So we didn't design this addition. That was Jacinta from Architecture in the Wild. So if you like the look, go speak to her. She did a great job on here, especially with the design lines. It even, it even matches our logo there, so we love those lines. I also want to praise my team of in-house carpenters on this build. They basically built this whole addition themselves, and that can be difficult. This addition had a lot of recycled materials specified by the designer and the client, and when you get repurposed materials, they can be difficult to work with. They're not always perfect, like recycled jarrah or bricks and stuff like that. So a lot of craftsmanship went into this particular build, and they did a really great job on that. They even poured the slab themselves, so a great effort there. So as a builder, we don't get a lot of choices sometimes when a design gets given us, but we like to talk through with the client some of our personal goals and sustainability criteria to build better homes, and these slides will go through some of those choices and some of those conversations we have with the client. As the builder and as designers, we like to, in sustainability, we like to focus predominantly on the building envelope, because it is the most important part of a home, we believe. It protects us from the wind, the rain, it provides the thermal comfort, and is one of the aspects that we can't easily swap and change out. We can often change a cladding or a kitchen or something like that, but the actual envelope where the thermal performance happens is really important. So we will start with the slab. One simple choice you can make with the slab is to use low carbon concrete. There's no reason why we can't use low carbon concrete in residential construction. Our slabs are pretty easy to design because they're sitting on a ground typically, so we don't need low shrinkage concrete or fast drying concrete, and it can reduce the carbon footprint significantly on a build. Now this job had significant amount of underfloor heating in it for the small spaces that were used, and we love underfloor heating. Slabs are great batteries for heat, not different type of energy, not electricity, but a heat battery. And you can see in one of those photos that there's very little solar access to some of these rooms. That's a wet area, and we can get that solar heat into those rooms quite easily by using a heat pump and putting it into those slabs that don't get access to natural solar light. On this project, we were able to do that using one heat pump for both the hot water system and the underfloor heating. So there's a coil in the hot water tank that can then transfer some of that heat across to those underfloor areas. So typically to heat a 315 litre hot water tank, it only takes the heat pump about 2 hours to do it. And we've got up to another 12 hours of sunshine out there that we can get that heat pump working, bringing that solar energy into the slab and warming up those slabs. Now, regardless of warming up slabs or not warming up slabs, slab edge insulation I think is the most important thing to do with a slab. It's the last part of the building envelope that isn't really insulated. We have double glazing typically now with high performance homes, even triple, quadruple is available. Our roofs can be fully, it's easy to pack lots of insulation in, walls are easy to pack but a lot of people forget the slab edge, and it's the last point of the whole slab, of the whole building really, that has access to ambient air temperatures. Even the underslab sits quite stably at 16 to 18 degrees, but the slab edge, you know, our weather here in Adelaide, we can have 0 degrees or 40 degrees, so great fluctuations, and that creates a bit of a thermal bridge. So this one's one for the nerds out there. I'm a bit of a building science nerd. Any other building science nerds out there? Yeah, a couple of you. Hopefully for the rest of you I can inspire you a little bit. But these thermal bridges aren't specific to this project, and I really wanted to show you these ones because this resource, the Finn's high performance construction details, developed by the Kiwis, because somehow they keep staying ahead of us a little bit, even though we hate it. But they've done a great job in. There's hundreds of details already pre-done for you. All the thermal bridge modelling is done for you. You can sit there and read it and compare what you're putting into your house and how it's going to perform. And you can even use those in your PHPP if you're doing a passive house or something like that. So all the work is done. And these are typical Australian, New Zealand details. You can see a 90 frame with a ventilated cavity and cladding. And then on this one, we can see the difference between a 90 no slab edge insulation and slab edge insulation at the bottom. And this is only using 25 millimetres of insulation. It really changes how the thermal bridge there performs. Now, we experience room temperatures predominantly through radiant heat, more than 50%. Whoa! All right, I've got to keep going. Let's. Sorry, I've got to go through it quickly now. So we use a lot of recycled materials. As we said, we've got reverse brick veneer in there. And we did, you might have seen in the earlier slides, shows sugiban cladding, which we actually burnt on site as well. And we implemented a fully ventilated facade. Now, with a fully ventilated facade, it can be hard to see going out to sustainable house days how it's implemented, but typically it's easiest to see around the windows. Because they're often at our eye height. You've got to see that there's there you can see a 20 millimetre gap above the window and a 20 millimetre gap below the window for the ventilation to purge out. So if you see those details on lightweight cladding or even brick veneer, you know that they're implementing a fully ventilated facade. I'll keep going. Now, we think pre-manufacture of framing is the future of sustainable building. While we don't have a warehouse and all the equipment to actually pre-manufacture yet, we implement the process already. This is what the outputs from CAD work, where every timber, has its length, and that makes ordering really efficient, site wastage really efficient, and we can minimise what goes in the skip bin on site. And we hope to see more pre-manufacturing in Australia in the future because it can be built in a controlled environment. Lastly, we blower door test all our houses. We have our own equipment. It is really easy now, even with just an external wrap, to get below 5 air changes an hour. As per the building code, if you go under 5 air changes an hour, you have to mechanically ventilate so that you get fresh oxygen in the house and you don't suffocate. Because this was addition, we didn't have to put it in, and we had no contracted air tightness requirement. But we still put in ventilation in their studio, which had 0 operable windows, and mould was growing in there and we could see water. So as a strategy, we put ventilation in there. So if you come see the house, you'll get to see some decentralised ventilation in action as well. And that's it. Thank you very much.